Okay, now we've returned to the first situation. We're done with the situation where the projectile's at a non-zero angle alpha. So the first situation, the projectile was in the horizontal direction, initially in the horizontal direction, and that of course corresponds to the alpha equals 0 case if you want to think in terms of this. That case, again, gives us the r of t function that we saw earlier, the v naught t I minus plus the negative 1/2 gt squared plus delta y times j. Now, the question that we want to ask here is, when is theta equal to 160 degrees? What do I mean by that? I mean by theta, I mean the angle at which the projectile is moving. So if you take any point on the projectile's parabolic path here, let's just take this point for example, then the tangent vector is going to be your velocity vector at that instant, the instant that the projectile is at that point. The velocity vector is going to be at some angle theta with respect to the positive x-axis. So we're simply asking, when is that angle negative 60 degrees, which means the projectile is going along here. When does it hit negative 60 degrees? Let's say that's the angle right there. It's a pretty steep angle. I'm flying to Texas tomorrow, right after class. If the plane hits a negative 60 degree angle, I'm giving up. You know, you're not coming out of that, at least not in a jetliner. Okay, well, not worried about that. Okay. Now we're going to assume, we're going to put some numbers on it this time. We're not going to do it all in symbols. We're going to assume that V naught is 10 meters per second and delta y is 12 meters, which gives us this equation, and that's extremely straightforward. Of course, g is 9.8 meters per second squared, so the negative 1/2 g will be negative 4.9 meters per second squared. And the 10 meters per second goes here, 12 meters. It's just this function with these parameters. Okay? So our v of t function is this. I'm not going to read it to you. It's right there. I think you understand what you're seeing. Now, what's the angle at which we're moving? Okay, the angle at which we're directed is going to be the inverse tangent of the y component of the velocity divided by the x component of the velocity. So the tangent of theta is vy over vx. And we can say theta is the inverse tangent of vy over vx plus 180 degrees if vx is less than 0. I put the dots there. That's part of the definition that you really need to remember. So what we have now, here's a picture. The 10 meter per second velocity in the x direction isn't going to change. Now this angle is going to change because the y velocity is increasing, so the angle is going to get increasingly steep. We have the v of t vector, and we have the negative 9.8 meters per second squared times t being the vertical component of the velocity. So the horizontal component is 10 meters per second. Negative 9.8 meters per second squared times t is the vertical component. There's our v of t. The angle theta is going to be what? It's going to be the inverse tangent of the y-coordinate, which is this, divided by the x-coordinate, which is this. And the x component of the velocity is 10 meters per second, and that's positive, so we don't have to worry about that 180 degrees. So the solution is rather straightforward. We got vy over vx is going to be the tangent of negative 60 degrees. That's what that's how we define the angle. And the tangent of negative 60 degrees is negative square root of 3, which is approximately negative 1.732. We can put our vy and our vx in here, set that equal, and that gives us an equation we can solve for t. And it's a very straightforward equation to solve for t. Just solve it. And you get t equals 1.77 seconds. Notice I got a neg every once in a while. I've got the units on every quantity that has units. I'm seeing a lot of work where the units aren't there. And if the units aren't there, all you're doing most likely is crunching numbers. You're not thinking about the quantities, and you're not thinking about what they mean. You'll learn physics a lot better, and you'll be a better engineer if that's your goal. If you understand what the quantities mean That's not a good idea unless you're under severe time constraints to leave units out of your calculations. You learn more, you learn better, you learn faster, and you check, you have a pretty good check against some very common errors if you do that.